Welcome back to our video module on mechanics and materials. In our previous video, we looked at the relationship between stress and strain and really ended up likening it to a spring, so that when we apply a force to some material, it has a little bit of springiness. And that springiness relies not on the length of the material, but on its material characteristics. As part of that, we made a parallel between the relationship between the force and the distance of a spring and stress and strain on normal materials. Let's take a closer look at what these graphs really mean. So over here, on our relationship between force and distance for a spring, we see that this graph has some sort of slope. And in fact, if you were to, say, use a stiffer spring for a small deformation, you'd have the same high force. Or if you wanted to use a really loose spring for a really big deformation, you'd have a small force. And if we remember our equations for forces and springs, F equals kx, where k is the slope of this line. In a similar way, we can see that with stress and strain, you can imagine that if we had a line here that requires a smaller amount of strain to get to the same force, that would imply a stiffer material. Likewise, we can imagine a different material that's, say, a little rubbery or less stiff. Just as in our spring equation, we can quantify this relationship as well. We know that the stress is equal to some constant times the strain. This constant is the Youngs modulus, and it is a characteristic of the material itself. So one can imagine that the Youngs modulus for steel is really high, and the Youngs modulus for something like a rubbery compound would be really low. So in summary, if we keep our understanding of a material feeling a little bit like a spring, feeling a lot like a spring, we see that in the same way we can quantify the relationship between the force and the distance, we can also quantify the relationship between stress and strain. Stay tuned for our next video.